see my screen. And with that being said, we're going to our handy dandy GeoPad. And what we are going into next is called the disk. And here is the disk. It looks like a, what do you call them wheels that the gerbils get on? A gerbil wheel or a hamster wheel?
One message coming in on secured
Think
channel.
of it as a hamster wheel, but think of it the width of a hair. And that is what we're doing. We're actually finding the area. I mean, not the area anymore. It's called volume because it's three-dimensional. Volume is three-dimensional. So if you were to draw this, which I cannot draw, it would look something like this. Kind of like a teacup.
Message coming in on secured channel.
And of course, you would find that volume by revolving around the x-axis. And that volume is a hair line disc. And that disc is going round and round the, it's going like that. And it's going up and down, just like it was showing you. And I can't answer that right now.
Priority 1 message coming in on secured channel.
And that's what it looks like. And it's going from A to B. Now it could start from 0, but this one is starting from A to B. And instead of something that looks like this, it looks like that. This is from 0 to whatever. And this is from A to B, not 0. So now what am I trying to get y'all to do? I'm trying to get you to visualize what we're going into, because a lot of this is based on what you see in the problem. Okay, so number 1 is going to be draw the picture. Okay, even though some of you think that's beneath you, you better draw it because it's going to help you out with these problems. And that revolution, and that's what it's doing, it's going around the x-axis. And it just does that with each one. And then when you do all of them, you've got the volume. Now, you see the excess here. You see the error. That is minimized when each one of these discs are the width of a hair. And when it's the width of the hair and going around the x-axis, it gives a pretty accurate volume. Capiche? This is what we call a disc because each one looks like a disc. Each of those 5 do-jiggers right there look like a disc. What happens when you change it? Well, this is what you call, that right there, that right there is what you call a ring. That right there is called a washer. I asked the mechanical definition of a disc with a hole in it. You know what somebody said? That's a donut. That's not a mechanical definition. A mechanical definition is not a donut. The mechanical definition is a washer. And this is a shell, sometimes called a ring. And with those three things, a disc, a washer, and a ring, you can do all kinds of good stuff. And you can actually find volumes in 3 dimensions. Now we're starting to get into the 3rd dimension, which you will get into in Calc 2. So it's very important that you understand what we're doing, okay? Very important. And you can go to the next one. Now, some of y'all may be seeing jet engine. Yep, you could say a jet engine. But that's where you got, this is a washer. And I'm just showing you different, and a lot of people are saying, well, why are you showing us over? Well, because you need to be able to visualize this. And a lot of people don't visualize stuff like this. It's not normal. Okay, so you got to get used to thinking in 3 dimensions. So hopefully y'all are starting to see it. We're going to do one of these. And let's see what else we got. Well, got all kinds of good stuff. Let's see. Here's, I don't even know if it'll pull these up. I guess it won't. I guess it won't pull it up. I guess. Oh, well. I don't know why it won't pull it up. Oh, well. And again, that's, now, how do we do disc and washers? Well, disc is given by the following formula. Well, let me first of all let you look at the disc. This is a disc. That's a disc. And you've got a radius. And you've got a height. So what is the volume of a cylinder? That's a cylinder. It's a cylinder like chopped off. Okay, think of a thick piece of bologna. Okay, this is a thick piece of bologna. Got the height of the bologna, you got the radius. But what is the volume of a
pi r squared a
cylinder? Pi r squared h. Now, I'm sorry, Mr. Paris, was that you?
I was trying to get it in, yeah.
How do you know the volume of a cylinder? You must have seen it before class. Nobody walks around knowing the volume of a cylinder. Are you just smart like that? Is that what it is?
The area of the circle times the height.
That's it. And I was wondering if he would say that. The area of a circle times the height. That's how you remember the volume of a cylinder. But this right here is not going to be h. Anybody know what that's going to be? It's going to be dx or dy, depending on which way you're revolving. And the radius is usually going to be the function. Okay, that red one is shot. The radius is usually going to be the function. So pi, you can take that out of the integration. So what does this mean? Well, that means that a disk, volume of a disk, is going to be equal to your parameters, A to B, of pi r squared h, or volume of a disk as far as x terms, pi A to B f of x squared dx. Write that down, because I just gave you your first test question, because I'm going to test you on disk, washer, and shell, or ring. Disk, washer, and ring, whichever one you want to call it. I like disk, washer, and ring because it sounds better. Disk, washer, and ring. So this is disk. So let's do a problem so we can feel good about ourselves. Let's do f of x is equal to x squared. And we're going to go, let me see, where are we going to go? We're going to go, x is from 0 to 4. And we are going around the x-axis. So the first thing you need to do is draw a picture. I want you to draw a picture of the graph. And then I want you to draw what it would look like in 3D. Would it look like you know, what I drew a while ago? Does it look like that? Or does it look like a half of a watermelon? Or does it look like the bud of a flower? You know, what does it look like when you draw it in three dimensions? So go ahead and do that. Graph it, measure it, go by the 0, 4, and then draw a disk around the x-axis because that's the way it's rotating. And then over by the side of the graph, I want you to draw a picture of what it would look like in 3 dimensions. You've got to get used to this. Those people that don't know how to draw, you're going to have to get used to it. If you're going into statics and dynamics, you're going to have to. So the graph, x squared, that one is dead. Hold on a minute, I'm going to throw these away. Okay, so x squared, f of x equal to x squared, that looks like that. But we're going around the x-axis from 0 to 4. So 0 to 4, I'm just exaggerating here. So it looks like It looks like this. There's our, going around like that. So it's going to start from here. So it's going to look like this. That's pretty good for somebody that can't draw. No, it's not going to look like that. Yeah. Let's see. Yeah, it's going to be this area right here. So I got it on its top. It's going to look like this. There we go. However you want to turn it, that's what it's going to look like. So now we're going to set it up. So V is equal to pi integral 0 to 4 of f of x squared dx. Okay, go ahead and do it. And what is x squared raised to the second power? X to the fourth, Hubert. Thank you, class. So that's going to give me pi times x to the fifth over 5, evaluated at 0 and 4. What happens to the 0? It's going to cancel, Hubert. Thank you, class. And the 4, I have no idea what 4 to the fifth power is. That'd be 16 times 16, which is some BA number. So we're going to do 4 to the fifth power pi over 5. And that is what kind of units? Cubed. So you just figured the volume of this top looking, the volume of this top looking feature, whatever you want to call it. Ain't that cool that you can actually do the volume of a three-dimensional object? Ain't that neat? And you know what? I asked somebody in the last class, I said, how many of you have been in a calculus class and couldn't make heads or tails out of this? And Mr. Smith, he raised his hand and said, it wasn't like that in the Calc 1 class. I said, it's all how it's presented. It's really not that difficult. Anybody in here had it? Huh?
So when you was talking about, you said the top part, since it's volume, wouldn't it be like the whole cone? Like, wouldn't that be what we found?
0 to 4, right here.
Yeah, it'd be like the whole cone. It wouldn't just be the top part, correct?
I don't understand what you're saying.
So you see how there's a circular part, and then there's the part that like starts to
0 to 4. Yeah. This whole area from here to here is going to make this kind of shape.
Yeah, and you're finding the volume of the whole shape.
Of this, yeah.
Okay.
Because that disc, as it gets bigger and bigger, it opens up here. So yes, you're finding the volume. With water, how much would it be? It would be 4 to the fifth power pi, and somebody give me a number to the second decimal point here. Somebody give me a number. To 2 decimal points.
0.02.
I'm sorry, what?
0.02.
No, that's going to be 4 to the 5th. That's a big ass number times 3 divided by 5. That's going to be like hundreds or thousands. What is
It's
it?
643.
3,000.
Okay, say it one more time. 600 what?
Are you asking for the total volume after?
When you do this right here.
Yeah, I got 643.398.
That's good. 398 square units. So, or cubic units. So, where'd you go, Mr. LaCroix? If I filled this up with water and this was like 4 inches, then the volume of this cup would be 643 cubic inches. You with me?
Yes, sir.
That would be the volume of this cup. All right, so let's do another one. Let me find another one around the x-axis. Let's do the opposite. Let's do this one. I'm going to let y'all do this one. Y is equal to x, square root of x, around the x-axis, and from 0 to 4. All right, do it. I want you to draw it. I want you to set it up. And I want you to give me the volume. And if you can't do it, Mr. LaCroix, you know, like Mr. Paris, just look at it as failure.
I'll get my cardboard box ready.
There you go. That's the way to think. You got to have that cardboard box. Sometimes I think Mr. Knight looks at me and he says, this guy's a lunatic. That's all right, Mr. Knight. Everybody's a little bit crazy. Actually, you're in the middle of my screen, and that's why I picked on you. Mr. Michelle already knows I'm crazy. And some of y'all are figuring it out. So.
Well, I mean, Hubert, it doesn't take a damn rocket scientist to know that.
How many classes have you taken under me, Mr. Michelle?
This is number 3 now.
3. You took, which other classes did you take?
I took college trig with you, which was Math 111, and I took statistics with you.
Yeah. I tell you, I like trig, but I don't like the identities because to me that confuses a lot of students. So I like the basic trig and I like the application of trig. But
oh yeah, the identities were absolute hell.
Yeah, they suck. Well, y'all will miss me next semester. I guarantee it. I guarantee you there won't be a single one of you that goes, God, I'm glad I'm out of Hubert's class this semester. All right. So I've got a square root of x looks like this. And I've got a I know, I suck at drawing. Don't even say it. There's my disc. And it's going round and round. So it's making a shape like that. And it's going, dang-o, looks like a half a watermelon. So we got a half of a watermelon. It's 4 inches. So what's the volume of that watermelon? A half a watermelon. Well, let's do it. So I'm going to do volume of the half a watermelon equals pi from 0 to 4 of parentheses squared dx. And x to the 1/2 goes there. Now finish it out. I need to take art lessons, maybe. I know I can do the seeds. I know I can do the seeds. There we go.
Hubert, if you did art class, the teacher would quit on you.
I know. I'd probably quit.
Or that's supposed to be watermelon lines.
Shut up.
They're going the wrong way.
No,
what
I'm
kind
trying
of
to show you
watermelon
that
do
it's
you like?
curved. Thank you.
Okay.
Nah, we know what you were trying to do.
It's all right, Mr. Lee Croy. You're in the dungeon anyway. Be quiet.
Man, what kind of watermelons are you looking at nowadays?
There.
Hubert?
There. Are you happy now, Mr. Lee Croy? There. Freaking
That's extremely better.
there. All right, so that's going to be V is equal to pi integral, that cancels, x dx. V is equal to pi x squared over 2 evaluated at 0 and 4. What happens to the 0?
Cancels.
So you're left with V is equal to 16 pi over 2, which is equal to 8 pi. And somebody give me, that's 25.13. And if we were saying that's 4 inches, that would be cubic inches. If 4 inches was the height. Okay, so I just kind of added that 4 inches to kind of give you some kind of perspective. So if you had a half of a watermelon that fit y is equal to the square root of x as far as a parabola, then you would have about 25 and 25, a little bit over 25 cubic inches of volume. So that means 25 1-inch cubes could fit in that watermelon. Well, what happens when you don't rotate around the x-axis? Then you quit, right? No, you rotate around the y-axis. Draw a picture. This time, your disc, your radius, is rotating around the y-axis. So I want you to draw a picture of the graph and what it would look like. Well, it's going to look like a half a watermelon again. and we're going to see if we get the same answer. You should. You'll see here in just a minute why. The reason is because the shape is still like a watermelon. And it has the same dimensions, except you're doing around the y-axis. So technically you should get the same answer as the one we just did. Now, there's some things you got to do here that's different. Y is equal to x squared. We know that. Looks like this. And we're going to 0 to 4. And here is our disk. And it's going around like that. And it's causing a solid disc shape. So that means that it's going round and round and round, and it's forming this picture. Now there's only one problem. We're going to take out our handy dandy pink highlighter. The rotation is in terms of what?
Y.
The parameters are in terms of what?
Y.
The function is in terms of what?
X.
So you got to change it. Do y'all remember those problems, those word problems, where you had feet and inches, and you had to convert either feet to inches or inches to feet? Do y'all remember those word problems? Same concept. Y, terms of X. So I got to take my handy dandy red marker, and I've got to solve for what? X to get this in terms of Y. So I'm going to go down here, since rotation and parameters are in terms of Y, we need to solve for X to get function in terms of Y. Now, why did I write that in red? Because when you're rotating around the y-axis and you have parameters in terms of y, then you've got to change this to a function in terms of y. A lot of people think solving for y is in terms of y. No, it's not. Solving for y is getting y by itself. Putting the function in terms of y it means to get the function in terms of y. So that means I got to solve for x. So x is equal to what? The square root of y. Or x is equal to y to the 1/2 power. Now you can set up your integration. Just go ahead and set it up. So antiderivative, or volume, equals pi times the antiderivative from 0 to 4 of y to the 1/2 squared dy. Now everything is in terms of y, so since everything is in terms of y, we can take the antiderivative of y just like we would x. Everything has to be in terms of y for us to do that. The y values, the dy, and the actual function. So the volume is equal to pi times the antiderivative from 0 to 4 of y to the first power dy. And v is equal to pi times y squared over 2 evaluated at 4 and 0. V is equal to pi, that cancels, 16 over 2, 8 pi. And you see you got the same answer. All right. Notice, what did I do? What do you notice about the way I do these? Step by what?
Step.
Step by step. I draw it. I look at what I'm given. I say to myself, well, this has got to be in terms of y. So I solve for, in terms of y, which means solve for x. And then I plug and chug. All right, I'm going to give y'all one. I'm going to give you 2-3 minutes. Sorry. Something on my phone just went off. All right. Y'all try this one. Y is equal to 1 over x. We're revolving around the x-axis. And we're going, x is equal, going 1 to what? 3. Now this one, going around the x-axis. But I want to see if you can switch gears. I want you to see if you can go from the x to the y. Draw a picture.
Gmail.
Mr. Caldwell, you look like you're scared. Don't be scared of it, Mr. Caldwell. He's looking like this. I just making sure you wait, Mr. Caldwell.
Yeah, I just had an email pop up on my computer. I was reading that real quick. Sorry. That's why I was looking like that.
So that looks like this. 1 over x looks like that. From 1 to 3 looks like that. And if we did it would look something like this. Kind of like one of those cone shapes on the stethoscope your doctor has. Like a stethoscope cone, or I don't know. Don't have a point on it. Don't laugh at me. Leave me alone.
Or it could be a megaphone.
Yeah, we'll put a handle there. There you go. And y'all wonder why I want you to, I do want you to draw it, because it's very important that you see what it looks like. And some of y'all might want to think of a trash can. So let's say this is a trash can 3 foot tall. Three foot tall. So everything's in terms of x. The four functions in terms of x. This is x and this is x. So volume is equal to pi from 1 to 3 of parentheses x to the negative 1 squared dx. And v is equal to pi 1 to 3 of x to the negative 2 dx. Now, did y'all notice how I just rewrote that in my head? That's what y'all should be doing now. If you're saying, where did x to the negative 1 come from? You missed the train and the boat back in derivative times. Because I told you, always rewrite a fraction or a radical. So you should just be able to change those gears real quick. So that's going to be pi, and that's going to be x to the negative 1 over negative 1 from 1 to 3. And I'm going to rewrite this. It's going to be negative 1 over x to the first, 1 over x. So that's going to be pi times 1 over x, be a negative 1 over x, evaluated at 3 and 1. It's going to be negative 1/3 minus a negative 1 over 1 times pi. Well, that's going to be negative 1/3 plus 3/3, which is 2/3. So I think that's going to be 2 pi over 3. Somebody check me, please. Somebody check my math.
That's correct.
So our wastebasket has a volume Somebody take 2 times 3, 2 times pi, take it all the way, use the pi, don't use 3.14. Somebody take 2 pi over 3 and just give me a rounded whole number. 2 pi over 3, what do you get?
2.
It's going to be around 2 cubic feet. Two decimal places, please.
2.09
Cubic what?
feet.
So this trash can will hold 2 1 by 1 by 1 cubes and 1/10 of a cube. Because that 9 raises that to a 1. So if you had a trash can that was 3 foot tall and it had the sides that fall along this, then you're talking about a volume of 2.09 cubic feet. All right, one final one before we leave today. But I'm going to let y'all do the whole thing. I'm going to give you everything, but this one's got a twist to it. Y is equal x to the 2/3 bordered by x is equal to 0 and y is equal to 1, and it's revolving around the y-axis. Now, if you remember your graphing way back, these are 2 lines right here. I wrote them different. I didn't write them in brackets. I wrote x is equal to 0 and y is equal to 0. So these are 2 lines. And it says bordered by. So draw a picture, and then you should be able to come up with the antiderivative. Miss Seiler, don't look so depressed. Where's your dog? Hopefully your dog will cheer you up.
I'm fine. I'm just out of it. I went to the dentist today and I can't feel half my mouth.
Oh my gosh, I hate the dentist.
I know, it was bad. It was bad. But I'm good. I'm focused. I'm good.
Now, Miss Levy, do you get out of work during this hour and a half, or do you actually have to look like you're working while you're in class?
I take my lunch during this time, so I'm available.
It's kind of a ghost. I don't see anybody in that room with you. You must be running the place by yourself.
About everyone heads out at 3.
I kind of figured that. All right, I'm gonna let give y'all a couple more minutes. You should have it drawn out at least. I mean, it's the exponent over index. That's the cube root of x squared. Or just graph it on a calculator. It's going to be a swoosh. So I'm going to use blue for the actual function. I'm going to give y'all a little hint. And we're going to use orange. Somebody tell me what that is right there. when I have x is equal to 0 on a graph, what does that mean?
It's
You're
at
at
the origin going up,
It's the y what?
the y-axis.
The y-axis. And what happens when I have y is equal to a number?
You have a line at 1, y equals 1,
And that is a, what kind of a line?
horizontal line.
Now, did I trick y'all or did I just make y'all think? I made you pull up that stuff from graphics. That's why in the previous problems, I had brackets and the letters. That means from 0 to 4, and the numbers from 0 to 4. This is not brackets. This is saying a vertical line and a horizontal line. So here's my region right here. So I'm going to take my yellow highlighter, and that is my region. And now you can set up your, so it's going to be looking like that top again. Looks like a top. That's what it's going to look like. So dy is the width. We've got y right here, and we've got our y's right here, 0 and 1, because that is in terms of y, and you cannot put a negative in here. So you know this above, so it's this area, so 0 to 1. Volume is equal to, wait a minute, we got to turn this guy into y. So I'm going to take my handy dandy red, 3/2, 3/2. So x is equal to y to the 3/2 power. So v is equal to pi from 0 to 1 of y to the 3/2 power squared dy. Finish it. Now I have to ask, is there anybody in here that would like to volunteer if they've been in calc before? This stuff wasn't that difficult. Was it difficult in that calc class? Just curious, anybody? Nobody's going to say anything, okay. How about you, Mr. Parrish? You're always talking about that former calculus class.
Mine was, like I said before, mine was quite some time ago, and I was not the best at paying attention. So, but yeah, this is not as difficult as the implications the word calculus would have.
It's not. Anybody else want to share that's had a calculus class before? I'm doing it for a reason, not patting myself on the back. I'm generally, there's a reason I'm going to tell you what the reason is. Anybody else want to share? Didn't somebody have a couple of people on Tri-County Tech's payroll last semester? Thought somebody did.
I definitely understand this
I-
better than probably anything in my calculus class last year.
Do you know why?
Appreciate it.
Presentation.
Yeah.
It's all how it's presented. If I present it to you like the book does, f of x and f of x and g of x and all this stuff, you won't grasp it. There's different learning styles, and a visual learning style helps with a lot of people. That's why I do the visual on the DoJigger, the Geo Sketchpad. I do that first because you need to see it. Then I transition from this to the actual graph, even though I can't draw. And then I go from the graph to this. And then you can see it better when you set this up. It's all about how it's presented. When I'm talking about the area, with the disc and the washer, and especially the washer. The washer, you have to look at the graph. So with that being said, let's finish this one. V is equal to pi 0 to 1. And what happens to the 2's? They cancel, Hubert. That's right, class. So that's y to the 3rd dy. V is equal to pi y to the 4th over 4, evaluated at 0 and 1. Lord, well, that's simple. V is equal to pi over 4. And that's square unit or cube units. So let's say that we've got a top. And those of you that don't know what a top is, it's your parents' fault. That's 1 inch tall. If you filled that top up with water, how much would it hold? I don't know, but somebody, what is 3? It's around 0.75. But somebody tell me what round to 2 places, please.
0.79.
0.79 or 75?
79. It's
So
0.785.
Inches cubed. So if I had a top, and for those of you that don't know what a top is, it's a toy. It has a little thing like this, and you spin it. And of course, if you've never seen one, it's your parents' fault. All right. So if I filled this top up with water, it would hold about 0.8 cubic inches of water. Okay, that's a good starting point because next thing I'm going to show you is the washer. The washer is a variation of the disc. What is a washer? Well, I'm going to show you because some of y'all have never seen a washer before. And it's real sad, but it's your parents' fault. Okay? I'm going to show you a washer. It's real simple. You just look up nuts, bolts, and washers. Nuts, bolts, and washers. Some of y'all thought, oh, that's the thing you wash clothes in. No, it's not. There is a washer. Okay? A washer is a disc with the hole cut out. This is no joke. I asked in the last class, I told y'all this at the beginning of class. I said, what is a disc with the hole in the center out of it? Donut? It's not a donut. It's a washer. Okay, that's the correct mechanical name for a disc with the hole cut out. It is a washer. It is not a donut. Does everybody understand? Okay. I just wanted to make sure you understood that because I don't want you to make a fool out of yourself in mixed company. Correct? All right. So let's don't say donut, please. That there's donut. Yeah, it's donut, Bubba.